What's up guys? Now in our last video I showed you this awesome all Intel games console that I've actually been putting together, and it turned out pretty good. It is the size of a games console, it plays games like a games console, but unfortunately it also sounds like a games console and it gets extremely hot too, which is affecting our performance. So today we're going to see if we can fix it. So for those of you that didn't watch the last video, I've been putting myself together an all Intel games console size PC, and to be honest, it turned out exceptionally good. Inside of it, we do have, of course, all Intel components now, because they do create graphics cards and CPUs, and it actually looks like a pretty decent system inside this case. It is built inside a Fractal node 202, which is a very small case, as you can see, but it's something that I've wanted for a very long time now, and it came up cheap, so I thought, why not? Let's just give it a go and do it. For the graphics card, we've got the Intel Arc A770. That is the limited edition model because that's the one we have, and the reason I chose this card was because of its 16 gigabytes of VRAM. I thought that would really help with modern games, particularly things like Indiana Jones, because they are very memory intensive games. And then for the CPU, we went for the Intel Core i7-12700K. Now unfortunately that CPU is probably a little bit too much for a case this size, because they do run extremely hot, and in particular we've only got this little 90mm fan system here from Noctua, which technically is supported by the CPU, but unfortunately when it starts to boost and things like that, it really can't keep up. And I suppose a little fan like this does give the authentic console sound, because it's continuously at full speed trying to keep all the temperatures down. But unfortunately the high temperatures across both the graphics card and the CPU were causing us some issues when it came to performance. Things were starting to dip and dive, particularly when you've been playing for a while. So we're going to have to do some changes here. We're not going to be changing anything else on this system apart from a bit of cooling, maybe the CPU. But I've actually been going out and purchasing some parts to hopefully fix this. For the first thing, we're going to be swapping that CPU out. Instead, we're going to go for an i5-12600KF. This is just a CPU that I had lying around. You could also get away with something like the 12400F, which is a pretty decent CPU, and it's going to offer you some pretty decent performance as well as pricing, to be honest, because you can pick them up for less than £100. These ones will cost you roughly around £130 at the moment, which still isn't too bad. It is still on the Intel's 12th gen, which is probably one of my favorite generations from them for a long time. And like I say, I had this one lying around and it should kind of keep things a little bit cooler, even though we've still got around 10 cores of processing on here. So that's going to be a bit of an upgrade or maybe a downgrade, but hopefully because of the drop in temperatures and things like that, hopefully it will be a bit of an upgrade. Along with that, we are going to also be swapping out the cooling solutions on this system. I have managed to pick some stuff up here. That's actually going to increase the cooling throughout the system, and we're probably going to be installing something like a contact plate so we can get the best thermals out of the CPU. But before we actually start unboxing any of this, of course, we've got to take this system apart. Now, unfortunately, to get to the motherboard in this system, you do have to pretty much take every single thing out of the case. There's not much left, and that's because there's just no space to be able to do anything. So we're going to put the carcass of the system over here, and we're first going to work on the motherboard itself. The biggest issue with this, of course, is the CPU inside of it, as well as this little tiny cooler from Noctua. So we're going to be first ditching that. We're going to have to take this cooler off, take the CPU out and start installing some more stuff. It's a very simple thing to do because this one just literally screws from the back, and you can take it off with just these 4 screws. And with the cooler off, you can kind of see the issue we've got here, because this is absolutely tiny. It's way too small for something like the 12700K. So probably a bit of a mistake fitting that in the first place, and they are quite expensive. So don't fall for that one. If you're going to be building something like this, go for something a little bit bigger. And I'm going to tell you now, it's not that easy to find something that will still fit in this case and perform better, but hopefully I've found something that will work perfectly fine. We've also going to be swapping out this CPU here, so the 12700K is of course coming out, and we're going to be using the contact plate for that. So we need to get our i5 out. I don't want to damage any pins, so we'll just take this out of the box here, swap the CPUs over, then we'll start taking the brackets off so that we protect everything as we go. Very simple to install, uninstall your CPU and install a new one. We'll just take the previous CPU out, we'll drop the new one in. Now all of our pins are protected, and we'll put the old CPU to the side. What we need to do now is, of course, remove these brackets here from the original bracket, and we're going to be fitting this contact plate here. Now this isn't anything amazing, it's just a very basic contact plate from I think it's Thermalright who actually did this one, and it says Intel 12th gen there. This is basically just going to be able to make sure that the CPUs can press down properly and get us the best contact we can with our cooler that we possibly can. We will need a little device here with the little hex screw to be able to remove the original brackets. These will come off in 2 places, so they're not like the old ones where it's a complete surround. You will need to just first take the first one off, And we also need to make sure that we keep the screws because they need to be used back onto the contact plate. It didn't come with its own. Take the screws out there. I'll store the old brackets in the box so we don't lose them. Usually I will store it in the motherboard box, so we'll move it to there afterwards once this is actually done. We'll remove the other bracket. Very simple to do. Like I say, make sure you leave your CPU in while you do this because you don't want to accidentally drop something on those pins, and you could quite easily do that with something like this. So what we need to do now is just drop our contact plate down. Now I've used this one in the past, so it's a little bit tight, but we'll get that on there. That should now particularly hold the CPU down equally across all of the pins, and we shouldn't get any kind of contact issues. Sometimes you can get contact issues with these LGA 1700 CPUs, depending on the cooler that you use. Sometimes people will tighten them down way too much and it'll bend the board, but with the contact plate you don't tend to have that issue. So we'll just tighten up these screws and the contact plate is actually installed. Now with our contact plate installed, it's time to introduce you to the fan that we've managed to pick up for this one. The cooler that we're going to be using is this one here from ID Cooling. It is the IS55 Black. Now the 55 means that it should be 55 millimeters high. The maximum height for a cooler in this case is 56 millimeters, so we are still pushing the boat a little bit here, but this is generally the shortest one that I could actually find. Most low profile coolers either come in this size here, or they do come in around about 67 millimeters in height, which clearly will not work for this case. This cooler here is far bigger than the one that we've had before. Just pop the cooler out here and you'll be able to see a massive difference straight away, because this one uses a 120 millimeter fan, which is a much bigger. It's going to provide a lot more cooling, and the heatsink itself is huge on this one. So hopefully this can keep up with the Intel Core i5 perfectly fine. This is rated for up to 150 watts. I believe the i5 is rated for up to 150 watts too. So they should be a great pairing together. But of course, we need to now get this installed. I'm not 100% sure which way it's actually going to go around, because there are multiple methods on being able to install these. It does need to go, I think, that way around there to miss and go over the top of the RAM. That will help us then also take heat away from the RAM itself, or you can, I believe, according to the descriptions on this one, you can put it over the top of the back IO shield if you want to, if you've got RAM that's a little bit taller, but we won't need to do that. We should be able to get away with installing it this way around, and that should then, because we've got super kind of low profile RAM here, that should fit perfectly fine. But of course we need to figure out first how to actually install this onto the motherboard, so we'll need some brackets. Inside the box we should have I believe a backplate of some description. So we have a backplate with this cooler that will need to be installed onto this motherboard. I'm hoping this is the LGA 1700 one. We'll soon find out once we put the pins for the back. We've got the backplate through now. That backplate is adjustable. It's just a little bit sticky in the corners, but we can basically now get all of the pegs through the sides, and then we will need to put the it's actually labeled here LGA 1700. We've got the little plastic things. They're going to drop over the top of the pegs, and then hopefully we've got some nice little screws here. Good thing about this fan as well is that it does come with the 15mm fan on the top of it. This is a 15mm depth here, which we will of course need for our case, but they do give you the screws to be able to fit the standard 25mm. So if you wanted to boost up your cooling and you've got the room for it, you can do it with this fan. This fan actually cost me, or this whole cooler actually cost me, about £34, which is much cheaper than the original Noctua. So if it does perform a lot better, this is clearly the choice we should have gone with in the first place. But I'm going to continue to install this on this motherboard, and then we'll jump on to the next upgrade. Now, unfortunately, I still couldn't fit the cooler the way that I wanted, because the RAM was actually slightly too tall for it, and it actually touched the RAM there. So I've had to kind of shift it completely round to face this way, and it kind of just about hovers over the top of the IO shield there. So I think that's actually pretty good to go. I've also taken the fan off the top of it, because we're not going to be using this fan on this system. I've actually got a different set of fans to use for this one. So we're going to ditch the ID Cooling fan for now, and we'll go into the rest of the cooling for the unit. For the rest of the cooling, I'm actually going to be installing some case fans, which is pretty crazy really, because that you'd think that case doesn't have space for case fans, but there are two which should help with the graphics card. And the fans that I've picked up are from Arctic. These are 120mm, 15mm wide, so we've got the most airflow that we can get through the system without using up as much space as we can. I bought a box of 3 of these for less than £20, so that's actually not too bad, and Arctic fans are very good. What I am going to be doing though is matching the one on top of the cooler as well. We're actually going to be installing one of these Arctic fans on top of this motherboard, but what I'm going to do is I'm actually going to turn it around, because if you watch a lot of games consoles, they do a lot of experimentation and research into how to get them as cool as they can, even though they run really hot, and a lot of them actually draw air through the cooler itself out of the system and push it out. Now our case is designed to be able to do that, so what I'm going to be doing is I'm actually going to be installing our fan the other way around, so it will actually draw air from the rest of the system and exhaust it out the top. Hopefully that will actually help with thermals, although not quite sure yet. We're going to have to test it, I suppose. So we're going to be fitting this fan in here onto this top. It's very simple. It's exactly the same size as the previous one, so we're just going to use the exact same screws. It's just turned around so that the air flows a different way. Now with the new CPU cooler installed, you can see the difference here. We've got a much bigger fan and a much bigger heatsink. Hopefully this will cool the i5 much better than the i7 was cooled with the Noctua. That should bring our CPU temperatures down by quite a bit, and hopefully we won't be hitting that thermal throttling anymore. But we also need to install a couple more fans onto this system. These fans are going to be drawing air in, and like I said before, they do actually provide two spaces underneath the graphics card here and here. We're actually going to be installing them this way round into there. They do take just standard 120mm fans, but we've gone for the nice little thin ones to hopefully add a little bit more airflow inside the system. This should pump nice cool air directly into that graphics card, and then hopefully the CPU fan can draw everything out of the system. Well, that's the plan anyway. So what we'll do is we'll install these fans into these places, and then we'll put the system back together again, and then we'll give it a bit of a test. Okay, so now that we've got the system fully rebuilt, everything seems to be working perfectly fine. Everything seemed to fit in the case perfectly fine, although there was a little bit of an issue with the power cable, particularly going over the top of those new intake fans that are just above the graphics card, or just under the graphics card. That was actually touching one of the fans on the graphics card, so we had to relocate that. But fortunately, it is long enough to reroute around the case, so you're going to have plenty of space to be able to do that kind of thing. And everything else seems to be working perfectly fine. In its vertical stand, which is the way that we tested it previously, it seems to be drawing a nice airflow in through the graphics card area, and is blowing a nice airflow out over the CPU, although you can tell a complete difference between how cold the air is on the intake and how warm it is on the exhaust. That is probably the typical pattern that you would have. I think if you were to actually have this horizontal, you would need some bigger feet. The feet that they provide are only about 6mm high, so that's of course going to restrict some airflow coming up through the bottom of the system. But you could always 3D print or buy some extra long feet if you really wanted to. I would actually run the system in a vertical sense like this, and that's exactly how we tested it in the previous video. So to be able to test to see if we've actually made any difference at all, we've done a few tests, one on the CPU, one on the graphics card in particular, and then we've retested all of the games that we did before to see if we get any more performance out of it. We actually used Cinebench R23 for this, and we did a 10-minute run on each system, the version 1 and what we're calling the new version 2. On the version 1 system, we got a minimum temperature of 40 degrees, a maximum temperature of 93, which is where it was touch and go before and starting to throttle things, with an average temperature of 76. Now the average doesn't seem too bad at all, but it was actually the peaks that were causing some of our issues there. And we had a multi-core score of 15,885. With the new system though, we saw a dramatic decrease in all of our temperatures across the board, now getting a minimum of 31 degrees, a maximum of 83, which is still within the bounds of the CPU not throttling, and an average temperature of 66. Now that is perfectly fine for pretty much most tasks, and Cinebench R23 with the multi-core test that we did is probably the most the system will ever see. This actually produced a score of 13,963, which is lower, but remember we did change the CPU out, so the i5 is a little bit weaker, particularly when it comes to multi-core testing. To test the thermals of the graphics card, we run a time spy test. On the version 1, we saw a minimum temperature of 63 degrees with a maximum temperature of 83 again. In gaming, after a while, that would actually increase up to around 100, but 83 is enough for the Intel Arc A770 to start throttling, with an average temperature of 75. We saw a graphics score here of 9,677, and with the version 2, again, we saw a massive decrease in temperatures here, with a minimum of 42 degrees, a maximum of 68, which is perfect again, and an average of 56. The average here which is what you would typically see in gaming, was actually a fantastic result, because it means that the games are not going to actually put this graphics card under too much pressure. And we actually saw a great increase in our graphics score because of this, all the way up to 13,223. So of course, under those synthetic tests, the graphics card, now being able to breathe, can actually get to its full potential, and we saw a massive increase in our graphics score, particularly on the time spy test. And we saw a huge decrease in the thermals around the CPU, which kind of went hand in hand in the fact that we are using a lower tier CPU now. It's much cooler, and the cooling itself is really getting all of that air out of the system. But has that actually affected the performance of our gaming? Now, of course, we had to retest all of the games we did before, and we retested them all in 1440p with a high preset. That is a standard preset, and we should be able to see a little bit of a difference here. But will we actually see a decrease in performance because we've switched to the i5, or an increase because that graphics card can now breathe and the CPU can get to its full potential without throttling as well? Well, actually, the results are pretty surprising. In Back 4 Blood, with the version 1 of the system, we managed to get an average of 128 frames per second with a 1% low of 65. Moving on to the version 2, we did see a small increase on this game, now getting an average of 133 frames per second with a 1% low of 69. Now, this isn't a massive difference here, so you won't really see much in terms of gameplay experience, but it's nice to know that there was a small increase on that game anyway. In Dead Island 2, we saw quite a significant increase here, with the version 1 of the system getting an average of 94 frames per second with a 1% low of 64, still providing a 60 FPS experience even in 1440p with a high preset. But with the version 2 of the system, now with that graphics card being able to breathe, we managed to get an average of 112 frames per second with a 1% low of 76. That is a pretty big difference here and will smoothen out the game by quite a bit. In Dying Light 2, we saw a very similar increase here, with the version 1 of the system getting an average of 75 frames per second with a 1% low of 59. Now with the version 2 system getting an average of 83 frames per second with a 1% low of 65. That increase on the 1% low there means that the game is now getting a very clean 60 FPS experience, at least in 1440p with a high preset, so that was really great to see as well. The one game that was actually a real struggle for the previous system was Hogwarts Legacy, and that's because it is very CPU intensive. The CPU in this game, when playing previously, would continuously throttle when the game started to get intense and there was a lot of characters on the screen. With the version 1 of the system only managing to get an average of 54 frames per second with a 1% low of 36. Not the greatest experience throughout, but with the version 2 we did see a bit of an increase here. We can now get an average of 63 frames per second with a 1% low of 39. Again, it's not going to make much of a difference in terms of the experience of the game, but at least we know now that there is a little bit more left in that graphics card when it's properly cooled. Indiana Jones was the feature game in our previous video, and in a number of settings we did manage to get it playable, but using a standard 1440p high preset. With the version 1 system we managed to get an average of 46 frames per second with a 1% low of 33. Not the greatest experience, I will admit, very stuttery throughout. And with the version 2 again, not increasing too much, but we did see an increase, now getting an average of 59 frames per second with a 1% low of 38. Again, not changing too much of the experience of the game, but it is much better, and you are going to be able to get just a few more frames per second out of it to make the game a little bit more smoother. In A Plague Tale Requiem, of the version 1 of the system, we managed to get an average of 48 frames per second with a 1% low of 40. Again, this game was very CPU intensive, so that wasn't a great score overall, but with the new version of the system, we managed to get an average of 60 frames per second with a 1% low of 47. Not too high there on the 1% lows, not much of an increase really, but with the average now around 60 FPS, you can kind of say that that game does provide a 60 FPS experience. Robocop Rogue City is where we were starting to hit the really super new titles now, the ones where this system, even in normal circumstances, really do struggle, and even with the version 2 of the system, it struggles still. With the version 1 of the system, we managed to get an average of 32 frames per second with a 1% low of 25. Not much of a change here with the version 2 of the system, managing to get 39 frames per second on average with a 1% low of 35. That is quite a bit of an increase really on those 1% lows, but again, it's not enough to really give you a smooth experience inside the game. And we saw a very similar result with Space Marine 2, again a very new title that really is demanding on most systems, with the version 1 of the system managing to get an average of 35 frames per second with a 1% low of 12, which was completely unplayable. But now at least with the version 2 of the system, we managed to get an average of 42 frames per second with a 1% low of 28. Still, you probably wouldn't want to play the game. It's not as smooth with that 1% low there, but at least it's getting better. In our previous video, The Last of Us Part 1 was a saving grace where we managed to get an average of 45 frames per second with a 1% low of 27. Not the greatest of experiences, but the game was actually quite playable. But now things are actually quite different with version 2, now managing to get an average of 59 frames per second with a 1% low of 42. That means the game is more than playable and perfectly acceptable for most gamers' experiences. But of course, those latter games in that list really are not designed for a system with this kind of specification, particularly at that kind of resolution and setting. Really, those games are 1080p games on this system, which is perfectly fine because I'm happy playing at 1080p anyway. So there we go. We have actually managed to improve our all Intel gaming console. It is a pretty decent system. It looks fantastic. It performs reasonably well in games. The only other thing we can really do is, of course, upgrade the CPU and graphics card at some point. We'll see what happens with the B series from Intel because we want to keep it completely Intel. But let me know in the comments below what you think of the system so far and the upgrades that we've made. Has it made a big enough difference for any of you out there that are using a very similar case? The parts that we used today didn't cost a lot at all. In fact, all of the parts that we purchased, and not including the CPU change, we would have gone for that originally if you wanted to. But for the extra cooler and the extra fans and the contact plate for the CPU, actually all cost less than the single Noctua small fan that we used previously. So if you are going to build a system like this, don't go for the Noctua one, particularly if you are using a higher rated CPU. Go for something from ID Cooling. They're really cheap. You can get some nice Arctic fans to kind of finish off the whole system. It works absolutely brilliantly. Don't forget to subscribe to the channel if you like this kind of content, and if you want to see this little PC going forward, I'm sure we'll do plenty more with it. And I'm sure, as always, I'll catch you guys in the next one.